So today we're going to continue with the unit circle, and we're going to start off by looking at the sine graph, and we want to explore some other properties and how else the unit circle can help us find some exact values for trigonometry. So when we first looked at trig graphs, we wanted to find, okay, well, for what values of sine theta could, let's say, 0.5 or 1/2 be? And what we realized that there are actually 2 points that can equal 0.5. Now, when we were looking at the graph, it was really hard to tell, but there is actually a method that we can use with the unit circle to help us be more precise. So these two values are going to be 30 degrees, and here it's going to be 150 degrees. So I'm going to show you what that looks like with the unit circle. So if I had sine 30 degrees, I'm going to draw up a small unit circle, and I'm going to have all stations to central. And remember, I start here. This is where my 0 is, and I'm going to work anti-clockwise. So here, 30 degrees will be about here. So here, that's a positive value. If I then look at sine 150 degrees, if I draw up my unit circle, I have all stations to central. Notice that 150 degrees is probably here. So that's about 150 degrees. But notice here that there's this little gap just here. Can you see that because these are going to be supplementary angles, that would actually be 30 degrees, which actually correlates to what we're seeing up here. So what we say in trigonometry is that sine 150 degrees is also equal to sine 30 degrees. And it's also positive because remember, in the first and the second quadrants, sine is positive. So let's continue if we have still a half, but what if we change its signage? What if we look at what happens when we have negative a half? So notice here, I'm going to have 2 points again. Now these points are going to be 210 degrees and 330 degrees. The reason I get these is that if I look at the unit circle, I have sine 210. I have all stations to central. Notice that 210 degrees is this entire angle here. And what you'll notice is if that I measure the angle between this vertical line here, so this line here, and this angle here, what I'll notice is that this is also 30 degrees. Now notice here that I'm in the tan quadrant. So what we can say is that if we put sine 20 into our calculators, that will actually give us the same answer as negative sine 30 degrees. Similarly, for the last one, if I had sine 330 degrees, I'm going to draw up my unit circle. $330 is probably at around here. That's this reflex angle here. That's 330. Can you see that the angle that is being made between this line here and the horizontal line is also 30 degrees? So we can say, and also it's in the cos quadrant, so that means sine is negative. So here, it is equal to negative sine 30. So if you were to put these values, these ones here, into your calculator, what you would end up with is actually different variations of the value of sine 30. So notice here that we look at all these angles in terms of 30, and the way that we call this is we call it a reference angle. So the reason that we get these reference angles is because we look at symmetry and we find it a much easier way to work with angles. So by symmetry, so this point here, can you see that if, for example, I wanted to find the exact value of sine 130 degrees, what I would do is if I were to measure 130 degrees, that would be this entire angle here. And can you see that it makes a 50-degree angle with the horizontal line, and we call that 50-degree angle our reference angle. Now, depending on what quadrant it's in, that determines whether the reference angle we're going to have a positive or a negative at the front. So if you can see here, for cos 130 degrees, if we were to draw that up in our all stations to central, So still we've got 130 degrees. We're making a 50-degree angle with the horizontal line, but can you see we're in the sine quadrant? So therefore, cos will be negative. So again, this angle that we're making with the horizontal line is called the reference angle. So we'll make that point here. So the angle made with the horizontal line is the reference angle. And we always measure to the horizontal line. So if we move to our next slide here, this one is a nice visual to show us what does it actually look like. So here my standard angle is going to be here, my green angle here. So that's what we were looking at before. We've got our green angle. I've got an obtuse angle here, a reflex angle to get into the third quadrant, and another reflex angle to get into the fourth quadrant. However, the reference angle is always the angle measured to the horizontal line. So can you see it's this one here, this little one here, and this one here. So we're always looking at making that angle with that particular horizontal line. So for example, I have these two angles here. Now here I want to find the reference angle. So I'm trying to find what is this equivalent to. So if I look at question 1, I'm not looking at what trig ratio, I'm simply looking for the reference angle. So here I've got 200 degrees. So the reference angle is going to be the angle that's between the line and the horizontal line. So here, if I think about my unit circle, I have 0, 90 degrees, 180 degrees, 270, and then back to 360 again. So here it's making it with 180. So the reference angle is equal to 200 minus 180. So the reference angle is actually 20 degrees. Now here, it's a little bit trickier. Again, I want to find this angle here. That's going to be my reference angle. So what I want to think about is if I've got negative 215 degrees, remember that it can also go backwards. So this can be 0, negative 90, negative 180, negative 270, negative 360. So if I had a negative angle, that way my theta would be equal to negative 215 plus 180. So with that one there, I would get negative 35 degrees. However, if you think about a reference angle, it is normally positive. So here, I would say it's therefore equal to 35 degrees. So let's look at some examples with trig ratios. So this one here, it's given me a specific section of the unit circle. So notice it's asking for an obtuse angle. Now an obtuse angle is looking at between 90 and 180. So here, what I'm looking for, if I think of my unit circle, what I'm looking for is if I have a reference angle of 30, what that means is I'm going to notice here that an obtuse angle will be between 0 and 180. So here, if I think about my obtuse angle, this is my line. I need to find the angle that makes 30 degrees with the horizontal axis. So can you see that this angle here will be, it's supplementary. So it'll be 180 minus 30 degrees. So it'll be 150. So therefore, sine 30 equals sine 150 degrees. So if again, I put that in my calculator, both should give me the same answer. Here I'm going to look at cos 57. All stations to central. Now, first thing is I've got cos 57 degrees It's an obtuse angle, so I know it's going to be in this quadrant here. And also this negative is telling me it's in the second quadrant. I'm going to draw my line and I'm measuring a 57-degree reference angle. And now I need to find the obtuse angle here. So the way I would find that is I'm going to do 180 take away 57. So the angle will be 123 degrees. So therefore, cos 57 is equal to negative cos 123. Now the last one here, I've got tan. I have all stations to central. So again, I'm in the second quadrant because I'm looking at my obtuse angle. I draw my line and I'm making an 81-degree angle with the horizontal line. So I need to find the obtuse angle, which is this one here. So theta is equal to 180 minus 81. So that will be 99 degrees. So tan 81 is equal to negative tan 99 degrees. And again, you can check each of these answers in the calculator, and each of these should give you the same result. So here now we're going to look at write the following using their reference angle. So now we're going to look at the opposite. So what if I have an angle that's not an acute angle, and then I want to find the reference angle? So first thing is I always draw again my unit circle. Now think about 330 degrees. That's going to be, if I think about, I'm going all the way around. So from 0 and I'm working my way around. So 330 will be around here. So that's my 330 degrees. So my reference angle is going to be this angle with the horizontal line. Now here, remember that I'm going up by increments of 90. So can you see that I'm finding the reference angle between 360 and the line? So here, theta is equal to 360 minus 330. So my reference angle is 30 degrees. So you could say, not that the question is asking, but when it says the reference angle, technically, can you see that sine 330 degrees is equal to negative sine 30 degrees. Now, the reason I have the negative here is because can you see the angle is in the cos quadrant? And sine is negative in that quadrant. So my reference angle is negative sine 30. Then here, I'm going to look at cos 162 degrees. So if I think about 162, I'm going to this angle here. So that's, make that a bit straighter. Here, I've got 162 degrees, and I'm looking for the reference angle, the angle made with the horizontal line. So theta is equal to 180, take away 162 degrees. So I'm left with 18 degrees. So now if I think about it, I'm in the second quadrant. So that's only where sine is positive. But because I have cos, can you see that it's going to be negative? So cos 162 is equal to negative cos 18 degrees. Lastly, I have tan 230 degrees. Now again, I start 0, 90, 180, and 270. So my angle is somewhere here. So here I've got 230 degrees, but I'm looking for the angle made with the horizontal line. So here, my theta will be equal to 230 minus 180, which equals 50. Now here, I'm in the third quadrant for tan, and I have the tan ratio, so that means tan will be positive. So tan 230 degrees is equal to tan 50 degrees. So the homework for today, you'll be focusing on exercise 6I and remembering that when you get to these questions here, ESL will be for every second letter.